In this video, I'm going to continue our discussion about the Palo Altos, and I'm going to talk about how to publish servers to the internet. Now, the first thing to probably clarify is what exactly do I mean by publishing servers? Well, here we have our network diagram, and in this network, we have a couple of servers down here that are in our DMZ. DMZ is normally where you would host something that needs to be accessed both internally and externally. And that's exactly what we have. So for instance, say here on the Linux machine, I want to install a web server. I want a client who might be sitting out here on the internet. This client out here on the internet to be able to access through the public VLAN, through the DMZ, this web server feature. And that's traditionally referred to as publishing. The different products call it different things. That's kind of the term I learned, and that's kind of what works for me. So if you've heard it as something else, not a problem. Go with that terminology. I call it publishing. Now, we don't want simply just the public IP address that's assigned to this Palo Alto firewall right here to be what's used. I want to give this web server his own unique IP address. So here's a more detailed listing of the IP addresses for our systems. Previously, we had gone through and we'd said, you know what, for your public IP address, everybody has a group. I am, for instance, group number 60. As group number 60, then that means like right here, my public IP address would be 10 plus 60, which means 70. Well, I'm going to do the same thing for my Linux machine. When I publish it, I want it to be 90 plus 60 or 150. And then for my Windows machine, it's going to be 70 plus 50 or 230. Why am I doing this? Well, there's lots of different machines, lots of different people who are all on the same public network. And therefore, I want to make sure that everybody has a separate IP address already assigned to them. Hopefully you won't stomp over each other, but you'd still bite. It always happens. So in order to do this, let's try to divide and conquer. Right now, the big question of how to do things is this guy right here, is the Palo Alto. So what I want to do first off is on my Linux machine, I want to install Apache. Apache is the web server that I want to use. It comes with a default, hey, everything's working page. So I want to install Apache and test it on that local machine in order to confirm, yes, it is working. The last thing I want to do is go all the way through configuring my firewall just to then have to find out, is my web server even working? The next thing I want to do is then find a machine that I can test it with. And I know what you're thinking. Out here on the public internet, we have internet. We have the internet, but we don't necessarily have machines to access this. And actually we do, because not only connected to the internet is the public VLAN, but this management VLAN is also connected to the public internet. So what we could do is with this machine, we could then type in 192 in a web browser. 192.168.116.150. There we go. My IP address will differ from yours, but .150. And what should happen is my client should go all the way through the internet, through the public VLAN, up through the firewall, and down. And then last thing we could do is actually configure the firewall. Now, just like when we configured everything to be able to access the internet, we will have to configure a security policy, as well as a NAT policy. And these guys, they get a little weird. Just the way things work in the Palo Altos and the way that the traffic is actually going from one point to another, they start getting a little weird. And so I found one way that always seems to work well for me. Try it out. There's many other ways to be able to do it. Do whichever one works best for you. So let's start off with our Linux machine. Let's configure an Apache on there and get it up and running. So I've got my Linux machine right here, and I'll go ahead and log in. Super secret password 01. Before I get started, I don't like this display. It's really kind of smallish, and I want to make it a little bigger. So I'm going to click up here where it says activities, and I'm going to type in display and check displays. You can notice by this window, it looks like I'm not seeing everything. The fact that the word displays is all the way over here as opposed to in the middle of the screen makes me think that there's more over there. I can actually click where it says displays there, drag down, and then move it over. My resolution is currently 800 by 600. Every single monitor out there supports 800 by 600. That's why that's the default, but I want something bigger than that. So let's go ahead and find something bigger. Not too big. 1280. Let's try that. There we go. That looks pretty big. Big enough anyways for our needs. Secondly, it was just telling me I don't have an internet connection. I may not have actually configured the IP settings. Let's come in here and configure the IP settings. Manual. Alright, this guy's IP address should be 10.1.1.101. Mask of ./24 and then 10.1.1.1 as the IP. And DNS is 192.168.116.2. Apply. Just to be sure, I'll turn it off the network and then turn it back on, and that should be everything I need. I'm looking at the little icon here. It's trying to connect. We'll find out shortly if it does. Alright, normally it doesn't take that long. Let me look at that setting again. Ted 11 101/24 10.1.1.1. That should be it. Oh, there we go. Okay, it just took a little while for the icon to show green boxes. All right. So at this point, I will go ahead and open up a terminal. I'll just click activities, start typing in terminal, and there we go. Make this a little bigger. All right, display's doing weird things on me. If you're familiar with Ubuntu, these next couple of steps will be pretty simple. We are using the command or the application called apt in order to manage and install software. So in order to do that, we start off with sudo apt-get update. This goes through and it updates the catalog on my machine so that I know which ones to get. And I'm actually somewhat surprised it is working. The reason why my initial surprise for it working is because in our management configuration here, we have permit DMZ to the internet and our applications. Oh, you know what? I may not have actually committed this. I was working on this previously and I had to roll it back specifically for this video, and I don't think I committed the changes. Alright, so once that's done committing, you'll see what I mean by why I'm surprised it was working. Alright. There we go. So now if I'm just going to up arrow sudo apt-get update and try that again. There we go. Connection fails. That's what I was expecting. Why was I getting connection fails? Apt runs over HTTP and HTTPS. You can actually see the URLs there. It's going to HTTP. So why would apt fail when we specifically allowed web browsing? And it comes down to the fact that apt is not a web browser. Apt is a different application, and therefore we did not allow that application to go through. So if we come back here, permit DMZ to internet to access the internet, and we come in here under applications, we allow DNS, SSL, and web browsing. We needed to allow apt. I know simply because I've done this so frequently, I just start typing in apt, and the application named apt-get shows up. I select it, it shows up in my list. I say OK and commit. And now we're allowing apt to run through the DMZ out to the internet. There we go. Okay, so if I had worked this properly at this point, I would actually do the sudo apt-get update. However, I did that right before this failure, so I already have an up-to-date catalog. So I will continue on with sudo apt-get install Apache 2. Apache 2 is the name of the program for the web server that we want. It says, hey, here's some stuff. Do you want to install it? Yes. And enter. So it's downloading the Apache files, it's installing it on the local computer and configuring it to run automatically. There we go. So now that I've gone ahead and I've installed Apache on this machine, I want to test it to make sure it works. I don't want to move on to the next step because I might move on to the next step and then never know if it's working or not. So for that, I just come right up here and I click the Firefox web browser. When I open this up, I can go ahead and I can tell it to connect to the local machine and show me if there's a web page. The easiest way to do that, here in the address bar, just type in localhost. That tells me to specifically look at my local machine. There we go. And I get a default Ubuntu web page. Now, instead of localhost, I could have typed in the IP address 127.0.0.1, which is also localhost. The word localhost just seems a little bit easier to type. Okay, so that tells me Apache's installed. Apache is running and working. And what I really should do, but I'm going to skip it at this point because I already know that this works, is I should actually log onto this server right here and try to browse the Linux web page just to confirm that not only is the Linux server running, but there's no firewall on the Linux machine blocking my access. In fact, if you're following along, I highly suggest that you do that. I did that myself about half an hour ago, so I know that it's working. Prove me wrong. Or prove me right. At least at that point, you'll know that there's no firewalls on the Linux server. Okay, so now I'm ready to start configuring my firewall. So I need to go ahead and start off with a security policy. All right, so we'll start off policy, security, and add. The name here can be pretty much whatever we want to call it. I'm going to call it Publish Linux Web Server. Source. This is where things start getting weird. Where is my source? Who is requesting the data and where is it going? If we look at our network diagram, in theory, over here we have out on the internet a client. And he is accessing the Palo Alto. So in this case, the source is probably pretty easy to see. The source is, in fact, the public network. However, in this case, the destination zone, is not the DMZ because we're not actually going through the firewall. And this is where it gets really, really weird. Just believe me and follow along and we'll see how it works out. Actually, in this case, the destination is that .150 IP address that we defined earlier. In that case, my destination is public. and my destination IP is 192.168.116.150. Okay, well, let's see how that works. So we come back here to our configuration. Source zone is public. Source address, well, ultimately we want everybody on the internet to be able to access us, so we don't want to specify a source address, but we want to leave it as any. User, we want every user out on the internet, so we're not going to worry about users. And then destination zone, like I said, is going to be public. And then the destination address should be that .150 address. So I could type here 192.168.116.150. However, that address means very little to me. Right now I know exactly what that means, but in about 10 minutes, I'm going to completely forget that. So instead of typing in an IP address, I'm going to create a new address and I'm going to assign a logical name to it. I'm actually going to call it Linux Web Public. So that's my server is the Linux machine, web is the service, and then public is the zone. Will hopefully help me remember what exactly I'm doing or what I'm using that for. So I type the IP address in there and there. Application, which applications do we want our users to be able to access that server? I'm going to go ahead and say web browsing. I could specify SSL. Right this moment, I'm just testing out to see whether it's going to work. So I'm going to stick with one protocol as opposed to worrying about multiples. Services or URL categories, we're not too worried about that at this point, so I'm going to leave those blank. And then action is allow. Okay, so hopefully published Linux web server is sufficient for everything I need from the security policy. So basically what that says is that the clients can come in from the internet. Oops, there we go. Clients can come in from the internet up to the Palo Alto and access that .150 IP address. At this point, it is the NAT that will continue and that will allow the packet to continue on down to the Linux machine. Now the NAT configuration is still weird. It's just as weird as the security policy. So follow along. In this case, let's see. So I called this publish Linux web server. I'll go over to NAT and I'll call add, and I'm going to call it the same thing. By using the same name, it helps me understand between the security policy and the NAT policy that these are in fact paired together to some degree. All right, so the original packet source zone is still public. Obviously, we're getting clients from the public, and our destination zone is still public again. Go and specify our destination interface, in which case it is 1-3, no source address, and then the destination address is the public IP that we previously selected. Now look, by having a name, I don't have to typo the address. I don't have to look up the address again. I just remember that's the Linux server for web functions and it's public. Nice. Makes life so much easier. By the way, I went through this about 5 or 6 times before I finally realized how helpful these names were. Translating the packet. This is where the magic really comes in. This is basically sliced into half and performs 2 different functions. On the left-hand side, we have the source address translation. So if we want to do NAT, do we want to translate the source address? Now, if you think about internal clients going out to the internet, you want to translate or hide your internal IPs. Therefore, you are doing a source address translation. The other side, however, is a destination address translation, in which case you are translating the destination address, the address of the destination, to an internal IP configuration. And this is actually what we want in order to allow our publishing. So let's go ahead and choose translation type here. And we want to choose static IP. Which address do we want to change? And this is where we need a new address. We have the Linux web public, but now we actually want to specify the DMZ IP. So I'm going to say new address, and let's call this Linux web DMZ. And now I type in the IP address of the Linux machine, which is 10.1.1.101. Translated port, I won't worry about that, and okay. All right, so now it looks weird. Our security policy, we can look here and we see we have published Linux server, source of public, destination of public, source of public, destination of public, destination of the Linux public IP address. Same thing for net. If we publish Linux web server, source public, destination address is the Linux public, but then we do some translation right here. So that's what actually puts it into the other interface. In theory, that's all we need. I'm going to go ahead and commit that, and then we will try it out. All right, commit is done. At this point, I should be able to open up a new tab and type in the public IP address that I'd specified for the Linux machine. So it's going to be 192.168.116.150, and I hit enter, cross my fingers, and it will go through. All right, maybe not. So let's troubleshoot it. First thing I want to do is I want to go back to my, let's see, I'm not even going to go to my Linux machine. I am going to go to my Windows machine in the DMZ. Let me open that up here. Look about my Windows machine in Active Directory, previously an Active Directory in the DMZ. I'm going to go ahead and try to just refresh this page. And it is working. Okay, so basically what that tells me is from the DMZ, there we go. This guy from the DMZ can connect that way on port 80 using the correct IP address. So that tells me that part is working. So everything inside the DMZ network is working properly. That means something is wrong with the Palo Alto configuration. Well, let's see if we can find out what that might be. First thing I'm going to do is I'm actually going to check those IP addresses that we just created. So under objects is where the IP addresses are stored. Linux web DMZ, that is 10.1.1.101, and that looks like the correct IP address. Linux web public 192.168.116.150, that looks correct as well. So my IP addresses look correct. So then let's look at our security policy. Publish Linux web server. Let me look at my notes while we're doing this. This is why notes are really, really helpful. Public, Linux web public, web browsing, and allow. Yep, that looks about right. Same thing for NAT. Publish Linux Web. Public 1.3 Linux Web public. Static IP Linux Web DMZ. That looks correct. Let me browse this one more time just to make sure. All right, still not going through. Let's look at the monitor. Yeah, it closed out. Let's look at monitor. This is where the fun really comes in. So here we can start looking at what our source and destination IPs might be, specifically for the traffic. And actually I need to add a little bit more into our policies. Under security, there is an interzone default, and I want to override some of the settings here. There we go. Specifically, what I want to do is under the Actions tab, I want to override and enable logging. What that does is when an error finally hits that very last interzone default, it will log an error message saying, no, you couldn't succeed. And that you didn't succeed message should tell me most everything I need in order to figure out what's going on. All right, initiate the traffic one more time just to make sure we can see it. And then there we go. Now we're starting to see some drops. From public to DMZ, from zone to zone, application NA. All right, so I went on pause for a couple minutes and I did some review to figure out exactly what was going on, and I eventually got it to work. So what I did was I looked through the monitor results here, and I kept seeing all of these drop messages, and I was wondering why the from zone was public and the to zone was DMZ. And then I looked at my notes and I realized I had it wrong. The from zone should be public and the to zone should be DMZ. So I went into policies and I went to my publish Linux web server, and I put my destination to DMZ as opposed to, so source, public, destination, DMZ. And now I then committed, and everything at this point is working flawlessly. So what I would do next, maybe I would customize this to allow more than just port 80 through. More than just web browsing, I would configure it for SSL as well. I might also start publishing my Windows server. Maybe I have DNS running on that. So I would actually just highlight this guy, clone him, and reconfigure it for the Windows machine or any other machines that I need to publish.